All right, so we're going to be talking about basically automation. As you can see, our awesome title to get it accepted, smarter design through manufacturing using the automation. So we're going to talk a little bit about SolidWorks and CamWorks. So that was bright. All right, so I'm going to be presenting with my guy, Mark Bissell here. He has been doing manufacturing in CamWorks forever. I want to say longer than I'm alive, but I think we're about the same age. But he's been doing it a lot longer than I have. So it's going to be really nice to see him take us through CamWorks. I was in the reseller channel before coming over to CamWorks. So I got all my cool SolidWorks certifications. So I'll be talking a little bit about the automation inside of SolidWorks. Let's go ahead. And you got anything you want to add before we get started, Mark? You good? All right, cool. All right, so let's go ahead and get started. Here is what we're going to be going through. Typical automation stuff that you may or may not have seen. What? Oh, it is not. No, thank you. Thanks, Mark. Wow, they weren't kidding about the leak, huh? I mean, I can move it and plug it into the one that's over here if you want. Okay. All right. One more second, I promise. We actually kind of know what we're doing. It just doesn't seem so just yet. No. I draw it on the side here. Let's see.
And in theory, it should be fine.
Look at that. All right. I don't know. I don't know if you should leave just yet. Something might happen. I don't know. If you can point big arrows pointing us to the room would probably be helpful. All right. So here's what we're going to be going through here. We're going to be talking about, the typical SolidWorks stuff that you may have seen. Equations, global variables. This is stuff that I love. So I've always loved it. So it's great to partner up with Mark and do this. Design tables, library features, smart components, SolidWorks APIs. And then when we move into the SolidWorks CAM automation or CamWorks automation, we'll be talking about the AFR, automatic feature recognition, of course, the technology database, setting that up to do what you want. So a couple clicks and you're off to the races, the tolerance-based machining, as well as the API inside of SolidWorks CAM and CamWorks. All right, so the first part we're going to talk about is the automation tools. And we're going to start off by talking about global variables and equations. And they're really straightforward. You could see a great example here, right? Anytime you see the little E, I used to call it the E. Everyone laughed at me. I believe it's a sigma, but what do I know? But that's telling you that it is an equation. So I like how they correlated that. So when you see that in a sketch, you know that you are using something of that, that kind of magnitude. And you could see at the bottom here, and this is what we're going to talk about when I show a little bit of it. But I can make these equations do whatever I want, and I can leverage any other components or sketches or dimensions that I have inside of there already and leverage them into here to have the design. So I'm going to start off with something simple. Okay, here we just have the formatting's a little weird, but it's just a lifting lug. Now these two holes do not match right now, so we're going to change that. But just to get started, we're going to take a look at the equations, and you'll see it's just basically set up. We have one number, and we're leveraging that one number to control everything else in our design. And that number happens to be 25 for now. So let's go ahead and edit the sketch, and then we're going to be able to take the holes and kind of size them so that that one number controls everything. It's really straightforward. We go to global variables, select that number, which again is that 25 number, and then we're gonna put a little equation on it, and then I want the other hole to match. That's even easier. I just have to use an equal sign, select the other dimension, and they're tied together. So now those holes will always be the same size no matter what. Now we could go ahead and look at a couple of the different things. So if I change that number, like maybe make it a little bigger or a little smaller, I think 35, and then you'll see that grows, but everything grew with it just by using that one dimension. The entire model, it doesn't fail, it doesn't break, we can update very easily. Now I use something simple, but imagine if I had a bunch of dimensions in there and they weren't linked. Every time I tried to change something, it gets a little bit out of whack. So Mark brought up a great point. He said, Paul, you know what? The lifting lug's a little simple, but I think it proves the point. But I wanted to throw in something else that I did, and that's this cabinet here. All right. Now, what I like about this is an assembly. So we have our typical cabinet numbers that we're going to control, right? Height, counter thickness, our kick size, and those sorts of things. Those are all in there as global variables. Now, if I go into my equation, you could see that all the different parts are referencing this main assembly. So the global variables that I have there are what's driving everything. So if I want this to be a different width or something else, I could go ahead and make that change. So in this case, we're changing, looks like I think I did I know I do the height and width, one in the order. I can't really see it, but I change them. And then when I update, you can see this cabinet's a completely different cabinet now. And all I had to do was change those couple dimensions. And again, I'm off to the races. Something like this, I could now nest it and do whatever I want with it. Moving on, I could even build an assembly of multiples of these, and then I can get my whole line of cabinets in just by controlling a couple different things. All right. Now, this is another thing that's very dear to my heart, and that is design tables, right? So there's a couple different things you could do. We're going to concentrate on the Excel design table. There is actually a table inside of SolidWorks that you can use that does not link to Excel. So if you're a company like mine, maybe, that no longer is using Microsoft products, maybe an Excel table wouldn't work for you. All right? And there's plenty of people that have, a situation like that. So the nice thing is when you install it, will tell you that you do not have a supported version of Excel. Somebody's smiling. He's seen that message. So, but that's what we're going to concentrate on, because I like the fact that it could be in or outside the program when you edit it. So I'm going to start off by showing you guys another super complicated design I came up with here. We're going to start by just showing you the design table that's in there. You can right click on any item and then hit configure feature, and it opens up that table. Now, down at the bottom, you do have to save it. If you don't save it, you could lose some of that information, where the design table doesn't do that. But you could see I could very easily add different items in there. I can make a configuration, and then I could drop everything down. But we're going to concentrate on the design table. So I'm going to go ahead and insert a design table here, and you just go up top to, I think it's Tools Insert, and you'll find Design Table right there, and it'll open that up. Once we hit OK, we're going to have a little Excel kind of table in there. And what I like here is everything pops up. I don't have to go and look for it. It pops up, I add what I want, and it comes right through the table. And once I expand this, we can add a couple little things in here. All right, so same thing, I have default as my configuration, and I have 25 as that driving number. I could go ahead and just type some numbers into that box. So if we were to go, 35, 45, something like that, we can add those in. I can then, again, it's just like I'm working in Excel, except in this case, I'm still inside my SolidWorks here. So I'm just adding some information in, and you can do the drag and drop like you do in Excel. I show that off a little bit later, but really straightforward stuff. And then we're going to go ahead and add the equations in. Now, in this case, we're using simple Excel techniques, right? I'm going to say equal. I'm going to pick that first number. That's going to be my driving number. And then I'll have some sort of equation. I picked easy equations, divided by 2, divided by 4 for ease of showing it off a little bit, but you kind of get the idea. And the last one is a small number, so we could do some, I think, divided by 50 or something like that. So here, and then I'm good to go. So that's all it takes to enter that. And then here, we're going to go ahead and drag all of these down just like we would other items inside of Excel, and it's going to populate all that. Now I can click out of here, and these are going to be automatically added. You notice the pop-up comes up, 25, 35, 45, the ones I just made, they get automatically added. If we look into our configurations, you can see that I can click on these, and indeed, they all in there, and this one's a little too big for the screen, but you kind of get the idea. Now, the other thing I could do is edit the table outside of SolidWorks. So that means I don't even need access to SolidWorks or the ability to, open it in any fashion. As long as I have Excel, I could come in here. You could see everything is there. Once again, I could type in the numbers if I want to. And then, you know, whether I'm doing the drag and drop, typing in the numbers, I'm creating all these additional configurations automatically. I feel like if I was doing this again, I'd probably do the drag in, you know, the drag inside of Excel. It's definitely a little bit quicker. But I really like showing off the ability to highlight all of these, drag down the corner inside of Excel, and it's reading that first number. And then I can now close down my Excel sheet, and you'll get that same message that we saw before. Everything gets added, and you can see I have all those configurations. Now, the reason I like this is somebody could be working on this file while I'm doing something different in SolidWorks. So maybe an engineering manager or a purchasing person, somebody else, somebody in manufacturing could go ahead and edit the Excel spreadsheet. Next time I open this part, we're going to get that message right there. So it gives you some flexibility in what your process might look like. All right, so I want to keep saying these are all my favorite, but that's why I wanted to do the presentation. But using library features. Now, when I was with a reseller or even now talking to clients or other resellers, I find that there's not a lot of people that leverage this, all right? This can be created with a simple drag and drop, and then you're reusing that feature. And what would be a reason to reuse it, right? You might say, wow, Paul, well, I got Toolbox, I can use that. Yes, you could. If it was a standard opening or a standard fitting, you can use Toolbox if it's in there. In this case, we're going to do something like this custom hole, and we're going to create it and then reuse it. And it's really straightforward. It's literally going to be a drag and drop. So here now I've designed something. This is a custom fitting for what I'm trying to do, yet we've decided, hey, you know what? If we order 1,000 of these, we get such a better price. Let's use these a lot more. I'm going to go ahead and just show you that there's a bunch of different configurations in here. All right, to start off. And then what we're going to do is actually create the library feature part, okay? So we're going to grab the items and we're going to drag them right to where we want them. There is an option to shoot and find the path, but I find it easier just to open this up and then just drag everything right over. Let go. Slow internet day. Somebody cut my line the day before, so it was a lot of fun. And you can see there's the path. I can name it whatever I want. In this case, we'll call it, you know, custom hole or something like that. We hit OK, and then we're going to see that our custom hole is located right over there on the right-hand side. And all of the features that I brought over are going to have a big L in front of them. So if you open it, you'll know, well, there's something different about that. You'll see the big L, meaning it's a library feature part. All right, now I'm going to go ahead and open up a block that has nothing. So now I want to reuse this fitting. Super complicated. I just grab it, drag it, pick a configuration. Notice it brought all the configurations over. And then it's going to ask me for the edges to locate it. And I'm good to go. And you can see everything's in there for me. And that's it. That's all you need to do to use a library feature part. All right, now take it a step further. That was just a library feature part. We can actually make smart components, which is kind of like a library feature part with even more cool stuff on it. So in this case, we have oh man, got too close, man, got burned there. All right, that's a first. I've never been tripped on by water while I'm presenting, you know, so there we go. All right, so library feature parts are components and features that we can bring over. So something like this, we have the red piece to hook onto, and we have some hardware holding it in place. We also have cutouts in the top. So what I want to do is take this yellow part, I want to be able to bring it into my assembly, place it, and have all this stuff magically show up. And that's what we're going to do here. So it's really straightforward. I need one to start with. So once I have this component, and I'm going to highlight it here, that's going to be my component. And you can see I got different cutouts and things. So if we look at the exploded view, you see all the cutouts underneath. So what we need to do is actually turn this into a library feature part. So we hit our drop down, make smart, I said library feature part, make smart component. You see it'll highlight the lifting lug first, and then it'll allow me to add parts. So I can use the drop down in my visual screen there, add everything to it, and then I can click the feature box. It will all go transparent, and then I can pick the features I want to be added. So now when I save this, that lifting lug is going to have all of those items with it when I bring, well, not when I bring it in, I got to turn it on, but they're all available to bring into my next, Here's a great example, and you could do it two ways. All right, there's 4 lifting lugs there, and yes, I do all 4. I can right-click and insert smart components, and then I pick the top, and everything's gonna come in. I can also highlight the item, and there will be a little Harry Potter lightning bolt on it. I can click that, and then everything's gonna come in. So depending on how you like to do it, you're gonna be able to come in and bring all those components in, and then we got it 2 more times here, and then I'll show you what that looks like. Hopefully you guys think this is pretty straightforward. So imagine the amount of stuff that you might be redoing. You could save it as an assembly and bring it all in, sure, but then you wouldn't have the cutouts as well. Turning it into a smart component eliminates all that. You bring in one piece, position it, and then turn on the smart component. Features, parts, everything comes right in, and you can see all 4 cutouts are on there. So that's pretty sweet, and that takes it to a whole nother level of doing that sort of thing. All right, so now let's talk about the APIs a little bit. There's a couple things you can do. Out of the box, SolidWorks, spoilers for Mark, CamWorks, you can record anything you want. So if you want to record something pretty straightforward, and I'm going to show you a couple different things, right? So, oh, that's user error. Let me go back one. Sorry about that, guys. All right, this one will be the recording. I gave a spoiler. So I'm going to hit record, and I just turned the macro toolbar on. That's all I did. And then I'm going to record myself making a new part. It's going to be a really complicated part, so don't be blown away by my SolidWorks modeling skills here. Nice. Looking good. 2 circles, you can't beat that. And then, yes, the macro is, yes. Yep. And then once I'm done recording, it allows me to save it. In this case, I saved it as macro 1. Pretty straightforward. And now, what do I do with that? Well, there's a couple things I could do. The first is I could just hit play, grab macro 1, and hit open, and it's going to do everything that I recorded. So this is like beginner, just dipping your toe into API a little bit, right? So I could do something like, oh, wow, I draw that. Now I could even take it a step further. Maybe I have a similar component that I want to make a macro / API of, but maybe I want to be able to change the sizes. So that's pretty straightforward. Let's say Mark made this mounting plate that I'm supposed to bring up, right? Well, I can leverage his API as well by actually making a macro button right in my user interface. So I'm going to go customize commands. Most of you have probably goofed around with this. I'm going to go ahead and add a new macro button. Drag and drop it up there. I'm going to now point to the macro. I could do macro 1, or I could do this mount that Mark did for us. And now I'm bringing it up. You can put an image on there. I didn't find anything cool. So I'm going to call it a custom mounting plate. Hit OK. And now I have that custom mounting plate option up top. So I'm going to go ahead and hit that. And now it's asking me for the size of the part. So I'm going to say 2 and 3 or 3 and 2. And then it's going to draw the entire mounting plate. And now I was able to leverage another macro having the button. And now I can make a bunch of these plates any size I want, kind of thing, right? That's kind of what we're doing here, right? Really straightforward. So we were able to take a look at the equations and global variables inside SolidWorks. Then we take a look at design tables, and keep in mind, there is a table inside of there. You just got to be a little bit more cautious with saving it, but it works just like Excel. So if you don't have access to Microsoft products, you can leverage that. Library features, which are cool. Smart components, which are even cooler than library features because it does both. And then we were able to take a look at some simple APIs inside of SolidWorks, just being able to record and move on. All right, I'm going to go ahead and turn it over to Mark, who is going to talk about some of the automation in SolidWorks CAM.
Thank you, Paul. Here you go. Can you hear me?
I don't know if you're on.
Check.
Oh,
check,
yeah, I can.
Check.
Yeah.
Check. How about if I stand a little closer to this as well? All right. Let's go ahead and jump in on some automation tools on SolidWorks CAM. And there's 4 levels of automation inside SolidWorks CAM. And I want to mention right up front, SolidWorks CAM is included in your SolidWorks. So everyone who has SolidWorks that's currently on subscription will have SolidWorks CAM as well. And SolidWorks CAM is a CAM system powered by CamWorks. So if you hear me say CamWorks once or twice, when I mean to say SolidWorks CAM, you'll know why. So there's 4 levels of automation inside SolidWorks CAM. It starts with the automatic feature recognition. We're able to recognize over 20 different types of machinable features on SolidWorks models using SolidWorks CAM. Also, I want to mention that the automatic feature recognition works exactly the same on imported models. So it doesn't have to be a native SolidWorks model that you might want to program on your CNC. So for those not familiar, CAM is used to program CNC machines. We are the CAM side of CAD/CAM, right? So SolidWorks CAM, we're talking about now for manufacturing the parts that you design, right? Automatic feature recognition will recognize over 20 different types of machinable features. The second level of automation is intelligence-based machining using what we call the TechDB or the technology database. It's a patented technology database that we use. It is you're able to store your best practices, your tools, your machines, and your best practices for machining. So your strategies for machining various features. When we talk about machining strategies, we're talking about 2 or 3 different operations, for example, might be more, might be just one operation on each feature, okay, to machine a feature. So for example, on a tapped hole, spot drill, tap would be an example of a strategy that would be used, a machining strategy. You can store your best practices in the TechDB and use those. Then the third level of automation is tolerance-based machining. And so tolerance-based machining will read SolidWorks MBD or DIM expert data and will select the correct machining strategies to meet the tolerance or surface finish requirements that are specified by the MBD or PMI data. MBD, PMI, DIM expert, all the same sort of thing, right? Dimensions on your models. And then SolidWorks CAM APIs, similar to what Paul just showed us with SolidWorks APIs, SolidWorks CAM also has APIs as well that are available. So this can automate using SolidWorks APIs and SolidWorks CAM APIs, you can automate the entire design through manufacturing process. Automatic feature recognition is the first level of automation, and you can see all the different types of features here that can be recognized automatically. You see over there on the left, milling features, pockets, holes, bosses, all sorts of different features on the part can be recognized automatically. You also see these are more manufacturing terms rather than cuts or extrusions or the terms that you would use for design, right? Also see on the right where turned features can also be recognized automatically using automatic feature recognition. Over 20 different types of machinable features, automatically recognizes multiple setups, so multiple sides of the part. Index angles is another way to think of it for 3+2 machining. It does drip on you, doesn't it? And and it also automatically populates the feature tree, the SolidWorks CAM feature tree for you at the push of a button. So it'll recognize all these features, put them in your feature tree for you. It'll divide them up, and we'll see that in a minute here in the video. And then it recognizes milling, turning, and mill turn features as well. So let's take a look at it in action. Here's a part with lots of features on it. There are 8 sides to this part. There are a whole variety of different features on here. I designed it specifically to highlight the features that are available. Is it playing?
Back it up. And going back for it.
Okay, let me try it once more. See if it'll play. There it goes. Okay, sorry. Yeah, don't know why it didn't start there, but you can see all the different types of features here. You notice tapered and filleted pockets on this part. You notice bosses, pockets, holes of all different types from the hole wizard, tapped holes, drilled holes, dowel pin holes. There's a whole variety of different features that are on this part. So I'm going to go to SOLIDWORKS CAM. I'm going to select extract machinable features, and it's going to automatically find all of those machinable features on the part, and it did it that quickly. That's real time right there. And you notice how there's 8 different setups there. So it divided them into the 8 different index angles or 8 different sides of the part that would need to be machined if you were on a 3-axis machine. It also grouped them all the different features. And if we go to setup 1, you can see the circular hole there and the set of holes there on the top on the first setup. So it divided them all. And because all the holes are the same, if all the holes are the same, it will automatically group them together for you as well. So create a group for them so that they can be processed automatically. On the second side right here, you see an open pocket with a raised island in the middle. Notice how it recognizes those islands and all that automatically. Slots, rectangular pockets, groups of holes. It's found all of those features. It's put them under each setup correctly. So really good feature recognition technology. In fact, the best that's available on the planet, right? Yes. Now, again, here there's an open pocket with raised islands. There's an ob-round pocket. And also you'll notice counterbore hole on this one. There's the ob-round pocket with some bosses, some islands. There's the counterbore hole. Created a whole group of those tapped holes, again, grouped them all together because they're the same holes. And then a couple of dowel pin holes in the center there that are going to be drilled and reamed. So all sorts of different features here. Again, an open pocket. It can really recognize just about any type of topology, right? And notice the different irregular pockets, ob-round pockets. It'll recognize all those different types of features. And this really highlights how powerful that feature recognition technology is.
Hey, Mark, quick question.
Yeah.
What you just showed, this would happen in that SOLIDWORKS CAM out of the box included, wouldn't it?
Yes.
Yeah, so
Yeah.
that same
What I'm showing you here is SOLIDWORKS CAM. It's standard, SOLIDWORKS CAM standard that you have on your SOLIDWORKS now. There's nothing that I'm showing you that is not already included in your system. Now, the ability to do 3+2 indexing requires SOLIDWORKS CAM Pro, okay, which is one level up. Very inexpensive if you talk to your SOLIDWORKS CAM reseller, and very powerful. Adds assembly machining, adds volume mill 2.5 axis for high-speed milling. It adds 3+2 machining. It adds the ability to program 2-axis lathes, are all included in SOLIDWORKS CAM Pro for very low price.
Then if you needed something more powerful, how complicated would it be to transfer all that SOLIDWORKS CAM information over to CAMWorks?
Right. So Paul's making a point here is that all the data that's in SOLIDWORKS CAM is also compatible with CAMWorks as well. So as you upgrade, you can carry that data with you and leverage all of the data. And we're looking at the different features here. There's countersunk holes, and finally the setup 8 here. And I think you get the idea, so I'll just go ahead. So the next level of automation is the intelligence-based machining. And the intelligence-based machining uses the patented TechDB, lower left right there, which is a SQL database, in order to automatically generate operations for the features that we just automatically found, right? So we automatically discover the features, and then we can automatically generate the operations. And you can capture your best practices. You can do that as you program using the tools and processes that you want. You can save them back to the technology database. And the next time it sees a feature like that, it will then use that strategy that you decided is your best practices. What tools, what feeds and speeds, all that. And it'll recognize it by material. It can also be stored based on size and so on. So this is great in terms of being able to fill the skills gap too, because when a new programmer comes on board, he can take advantage of an experienced programmer. I almost said old programmer, experienced programmer that has put a lot of their knowledge into that TechDB, a lot of the processes that they use successfully to be able to machine parts, right? And you can automatically select your machining strategies, tools, feeds and speeds, and depths all come from the technology database. So a little bit of animation here, and you can see the part being cut up at the top there. So this is the idea of being able to store your best practices and reuse them.
Now, I did notice that, in the standard CAM work, with the SolidWorks, so face milling wasn't actually part of the defaults. Part of the default automating, you have to go in and kind of like, select that. Is that a reason why that's so?
Yeah, so you can, for face milling, and you're right, face milling as a default wasn't included. The idea was that you would be able to pick the face mill that you want, program that face mill for your first part, and then store that back to the technology database, right? Face milling is one of those things where it's kind of done a lot of different ways by a lot of different people with a lot of different tools, right? You might have a small face mill, large, so on. You might use an M mill even to face mill. Some people do, rather than using a real, a full-on insert face mill, that sort of thing. So automation using SolidWorks CAM, how does this really work? It recognizes a feature. It gets added to the feature tree up there. So for example, that irregular pocket that's in the part gets automatically added to the feature tree. Then that feature is identified and it goes through the technology database. The technology database looks for an irregular pocket feature with the rough and finish strategy assigned to it. And then it identifies what machining strategy that it actually wants to use. And lower left right there, you can see some formulas as well. So formulas can be used for choosing the right tooling and so on. Once the strategy is found, you can then push a button and it'll generate the operations for machining and then generate the tool path. So let's see it in action. Here's a part we might want to program. Timing cover for a V8 engine. I'm kind of a classic car guy, so this was...
Like Chevy.
Yeah. Happens to be a Chevy. Good eye. Yep.
Mark is a huge car guy. If you're doing car parts, he's the guy to talk to.
That's right. So SolidWorks CAM, I'm going to go to the SolidWorks CAM manager there. Oops. Back. Yeah. Sorry. Started to point and So yes, Chevy timing cover. I'm going to go to the, and by the way, once SolidWorks CAM is activated, it's an add-in. It's under your add-ins list. You can go and activate it. A tab will be added to your command manager. The SolidWorks CAM tab gets added to your command manager. And on that tab, you will find the extract machinable features that we're talking about. There's also 3 tabs that get added to the property manager. A tab for the tools and the machine. So these are the tools, and you can have a default machine or a list of your machines. There's one that can be the default. Then here is the operations tree, and this is the feature tree. So we start with the feature tree, and we'll go ahead and extract the machinable features on the part. So this will find all those machinable features. This has 2 setups on it. There's your machinable features with the two setups, and we saw that earlier, how it can discovers those features automatically. There's a few features on the backside that also need to be machined. This is that face feature that you mentioned. And then the open pockets, irregular pockets around the part, different irregular pockets, circular pockets. So it's identified all the different machinable features here. Counterbore holes, and again, groups them together if they're all the same size. In this case, M8 tapped holes, 8mm tapped holes, what we have here. And I made this a metric example rather than just inch for my friends in Europe who also demonstrate CamWorks and SolidWorks CAM. Now it's going ahead and generating, so I hit the generate operations button and it creates all those operations for machining those features all that quickly.
You must have sped that up, Mark.
It happens pretty fast. Now it's generating the tool paths for those different operations. And by the way, those two steps you can also have happen automatically. There's a setting for that if you want it to just go ahead and generate the tool paths for you without having to hit the button. Now it's been fully programmed and I can go ahead and simulate it. So in a few clicks and in a few minutes, less than a minute, really, I can program this part in its entirety and have a program ready to go to the CNC machine. I don't think there's another CAM package on the planet that can keep up with this like this. Not within a minute, okay, on a part like this. Notice I compare the machined model to the design model. Everything in green has been fully machined to the design. If I gouge the part anywhere, it would be in red. And what's in blue, it would have left stock. You notice some yellow holes there where the model was modeled as the minor diameter of the thread, the drill size for the hole. So it was modeled that way rather than the major diameter for the thread. They're in yellow. I can also interactively create features. So here I have a sketch for the backside of this where I'm going to do some engraving on that raised boss right there. You can see what I'm going to engrave in there. In this case, CamWorks. So I'm interactively creating a feature. It only takes a few clicks really to do that too. There's that curve feature that I've generated, created interactively. Now I generate the operation plan. Now I generate the tool paths for it. And now that is included in the program as well. So it only took that long to add the engraving to this product. And you'll see it here, where now it engraves the CamWorks into the part for me. Okay, terrific. So we've seen automatic feature recognition and intelligence-based machining. Now tolerance-based machining. So you understand now the basics is that we have the features and then we have the operations, right? And the technology database generates the operations for us. The features and operations are based on what operations get created are based on the feature and the strategy that's assigned. So what tolerance-based machining does is it looks at the MBD data or PMI data or DIM expert data, whatever terminology we want to use, and it then looks at another table that we can create to decide what strategy we want to use. So in this example, there is a close tolerance pocket, and based on that plus or minus 0.08 millimeters, which is pretty tight, it's going to select a particular strategy called precision pocket machining, right? So it's going to then, instead of using the default strategy, which is up at the top, the rough finish strategy, it's going to instead select the precision pocket strategy. And you can see it here because then it's a rectangular pocket. It's going to use the precision pocket strategy. It is then going to use this different set of machining operations so that the pocket is semi-finished and then finished so that it's precision, right? And here you can see where it selects that strategy based on those settings. So here it is in action. There's also the ability to recognize surface finish symbols. That's what you see here. There's also the ability to recognize GD and T. So geometric dimensioning tolerancing has been added over there on the left. There's a geometric dimensioning true position call out that has been added. There's the precision pocket that we just saw. And then there's also ISO 286 on the backside. So we also support the ISO 286 tolerances as well. So based on the settings that are in my technology database, and also here you'll see the TBM table. So here's the TBM table, tolerance-based machining. I have different strategies and different colors assigned for the 32 finish and for the 64 finish, right? And for the 125 and the 250 as well. So different machining strategies for each one. Different color will get assigned to each one as well. And then here you can see the GD and T that I mentioned. There's a true position call out right there. And down there is the true position and the strategy that I'm going to use based on that tolerance. And notice it's within a range. You can specify the range. Here's the ISO 286 tolerance. It's based on the G7 ISO 286 symbol. It's within a range also for the size of the hole. And then I'm going to select a particular strategy based on those different annotations that are on the part. What's that? Throttle body. Yeah, well, kind of. I had that in mind when I was doing it. Another car part. Sorry. It's interesting too, just yesterday, there's a gentleman here from Australia that is interested in the CamWorks for doing engine blocks, LS engine blocks out of billet. They're machining them. And this is a perfect application for him because, they're doing families of parts. It's basically all LS blocks, but so basically engine blocks that are very similar. They're all V8s, they're all same bore and stroke and that, but they also customize them a little bit for each application, for racers, for other applications, right? Boats, some are boat motors, some are car motors, some are for racing, some are for drag, some are for the street, like that. So they make modifications to them, and so it's a great family of parts, so to speak. I call it families of features because it's even more powerful using CamWorks. And so it's ideal for that. In fact, we have a customer, CP Carrillo, who has automated the pistons that they manufacture using the CamWorks product. And here you can see it now has generated the operations, and it's selected the operations based on the tolerances that were specified. And you'll notice here where the different strategies have different surface finishes in order to reduce cycle time, really. So in other words, why make it a better finish than it necessarily needs to be? And you can see the different 32 finish, 64 finish, 125, and 250 finish on each of the, and then it goes ahead and selects and creates the other holes as well, and uses the strategy based on the tolerance-based machining. We don't have a lot of customers who are leveraging this. This is something that I think has a great future. SOLIDWORKS APIs, SOLIDWORKS CAM APIs, similar to SOLIDWORKS APIs, You can automate the CNC programming process using SOLIDWORKS CAM APIs. API help menu with UI is available within the system. There's an extensive library of the COM interfaces that are in the help file. So if you're interested in and learning more about you see over there on the right about the library and the different interfaces that are available. And we provide sample coded files to you as well. So lots of sample coded files, good sample coded files that you can use and cut and paste out of those files to create your own APIs. And you can use the SOLIDWORKS macro toolbar and to create, run, and edit the macros, and the icons within the SOLIDWORKS, to create and execute the macros. So similar to what Paul did in this video, what I do is add a customized button for doing all the things that we did to this part earlier in one click. So over there on the left, before I went through the extract machinable features, I generated the operations, I generated the toolpaths, and then I simulated the toolpaths, and then you can go ahead and post-process the file, right? I'm gonna do all that in one click using an API. So by automating the process, I don't have to click through the different processes. I can instead just create a single button. I call it a one-click button. You can see I'm naming it here. And I also gave it an image here. I have an image file that I typically use for APIs. It says API. So I can recognize it. So there's the API one-click button has now been added up there. I'm gonna click on it, and all those different things are gonna happen automatically. And it's even going to post-process the file, generate the G-code, and write it to the disk for me all in one click.
So extremely powerful, and you can also see how the automation leveraged to really speed up the process.
Those were like similar products, or like, for instance, when you have the previous product where it has multiple surface finishes that you're selecting, like if you import something completely different, is it automatically going to know based on the surface finishes what strategy to pick, or is it still going to have to fire a lot of constantly competing with it?
Great question. So with the TVM, if you specify the surface finishes, it would then automatically be used. Right? So it would not be interactive. But you're making a good point in that, let's suppose we didn't have the surface finishes specified through the then we would need to interact with it. I want this one to be a 32 finish. I want this one to be a 64. This one to be a 5. Right? And anytime you're having to interact with it, you can still have macros on either side of API you interact with it. But you could run up to a certain point and have to pick a few things, or even type a few parameters and then interact with it for API finish.
So it'll run up until it gets to some sort of issue that you need to interact with. Doesn't stop.
Yes. Yeah, and if there's places where you can expect that to happen, right? You know.
Is there a limitation on axes on machine running? I mean, most of this is like a 3 axis higher than that or something like that. Still going to be able to run some of those macros in it. Still that have to say like, oh, I'm running on 5 axis.
Right. Another great question. So the SOLIDWORKS CAM Pro will be 3+2 machining, CAM 4.5. Okay, you can have APIs run all the way up the line. In fact, I mentioned about the pistons that were being done automatically. That in that shop they had 3, 4, and 5 axis. Some of the pistons didn't need 3 axis, right? Some of them required 4, and some 4 and 5 because of the undercutting, different configurations. These are all custom pistons for racers, all kinds of pistons. Racers of boats, racers of bikes, cars, racers of trucks. right? So they have like all their own type of business that they want. They were all one-offs, okay? Typically one-off is prestige.
Hey, Mark, can I add something?
Yeah.
Sorry, you were talking, for the tolerance-based machining, you only actually need DIM Expert, which is already included. You don't need MBD to do it.
Yes.
MBD is, Mark and I, that only is going to produce your 3D PDF and do some other things. You don't actually need that to run the TBM. So if you put the surface finish and dimensions in using DIM Expert, you can leverage the TBD, right, tolerance-based machining right out of the box.
Right.
Sorry, Mark.
And it comes with SolidWorks CAM too, standard. So,
Oh, you spoiled the
Yeah.
slide. I was going to ask you about this. So everything, everything we showed you, we actually did use regular SolidWorks, but as most of you know, we are at 3D Experience World. So if you bought a brand new seat of SolidWorks, they're going to include 3D Experience, and there's a connected version of SolidWorks. I was going to ask Mark about how SolidWorks CAM or CamWorks works inside of that, and it looks like he already had a slide ready. So
yeah.
I guess I'll just be quiet and go back off in the corner for a little bit.
No worries, Bob. So we have now also have the CamWorks versions that we are releasing 2025 and forward will all be compatible with 3D Experience SolidWorks as well. So if you have SolidWorks Connected and you're using the SolidWorks Connected version, which is the 3D Experience platform version, you can also use SolidWorks CAM or CamWorks and so on. Now, one thing about that, I will say, it's the SolidWorks CAM standard was not included in the 3D Experience version. So that's something that, and we have a very inexpensive version that you can purchase to add that to the SolidWorks Connected.
SolidWorks CAM Pro, Mark and I found out does.
Yeah,
Sorry.
no worries.
So if you have a license of SolidWorks CAM Pro, when you install 3D Experience SolidWorks, it'll actually prompt you for the serial number. If you type that in, then you'll have SolidWorks CAM Pro running as well, just like CamWorks. Yeah.
Right. If you wanted to add SolidWorks CAM after you start running the SolidWorks CAM Connected, you will need to purchase a very inexpensive version. And the new versions are fully integrated in SolidWorks Connected. They're fully compatible with other previous versions of SolidWorks CAM and the desktop versions as well. They have the same great features. So the automatic feature recognition that I showed you, the intelligence-based machining, all that is included in the 3D Experience SolidWorks versions. All that's available as well. Tolerance-based machining and the technology database. In fact, you can use the same technology database for your desktop versions and the connected versions. Either one, they can point at the same TechDB if you want to do that. And I started to mention too finish that on the pistons, is that the macros or APIs they wrote, they had automatically select what machine. So it automatically determines if it's a 3-axis, 4-axis, or 5-axis machined part, and then automatically selects which machine that it needs to generate code for.
Is there also like machine, like brand limitations? Because I've ran into that a few times with other softwares, especially when you post them, that some of them, the machines do not like some of the post-processing that other do. Like even, MasterCam that we currently use right now, there's like 4 machines that will not use MasterCam. It crashes the machine all the time. You have to use their proprietary stuff. This is going to work. I've obviously saw a lot of cost machines like that. Are there other machines, that this is, I guess, more pointed towards, or are there brands of machines that this wouldn't be, I guess, good for type of thing?
So we've been in business a long time with the CamWorks. In fact, we started back in '98, back with SolidWorks. That's how long CamWorks has been around. We were the first gold partner. So we've been building posts for that long. We've also now distributed into Europe. We've been in Europe for many years. Okay, so the Heidenhain, the Siemens, those controls, we have those down pat now. Okay, for years we have. So you know, these days, and by the way, some of the Italian routers are especially difficult also. The CNC routers, yeah, those are, there's lots of fun. Yeah, I mean, the code is just wild.
States, obviously, they have just none of it works very well.
Right. Yeah, so we've done a lot of development on the posts over the years. So yeah, our post library is probably as strong as anybody's on the planet, really. So
So
there are exceptions. There are always exceptions. You know that.
Yeah, and there's always limitations.
Yes, because
I might be jumping ahead,
yeah.
but.
Go ahead.
So like, in my development cycle, we'll usually basically export all of the files out. I'll send them to our machine shop. He generates the code based off of that revision of the part.
Yes.
That way, if I change anything within it, it doesn't mess any of his previous code out. And if we want to revert back to that, we can. Does that also track that? Like if our machinist is in here generating code and then I update something, is it automatically basically going to crash his system? Where one person has to be at a time, like how revisions within that system work.
Yeah, so I mean, you're talking about revision control, really is what we're talking about now, right? And so one of the nice parts about the CamWorks is we also support multiple configurations. Just like CamWorks has, or I'm sorry, SolidWorks has multiple configurations. CamWorks or SolidWorks CAM has multiple CAM configurations. So those can be used in different ways. One of the ways is to do families of parts, right? Another way that we have customers using the different SolidWorks CAM configurations are for revision control. So they can save, he programs a part, he's done with it. He can save that under a configuration, and then he can go back, he can actually make a copy, and then he has both, right? And then what happens, if you make a change, it'll update the toolpaths automatically to his new, but if he wants to keep the older revision, he can keep it under the previous configuration.
Works
right?
well when machines go down too. You could just copy it over and then switch the machine out on the new configuration, and then the old
Post it
one
out
stays
to
there.
another machine
Very
is
common.
what Paul's
Yeah.
talking about. Yeah. Another way customers use it too is for different parts that go across different machines. So they might have a lathe configuration for turning, you know, or mill turn, and then they have another configuration for milling, right? For milling the same part, right? So two programs. And by the way, in all those circumstances that we're talking about, in other words, multiple configurations for families of parts, multiple configurations for different machines, all of those toolpaths are associative to the original design and even in assembly mode and all that. So if you make a change, it'll update all those programs, right? It could update the lathe program and the mill program or 2 or 3 mill programs all in one shot. And huge time saving. We have the different, got to wrap it up here. We have the different packages that are available. You can see the growth path here. And we're down in the hall at 1029, I want to say. Is that right?
Is that?
The booth number?
Oh, I don't know where booth number.
You can't miss it. Well,
That's a
HCL
good
CamWorks
question.
there's a big circular sign.
You would think we would know that.
ACL
Look for the
CamWorks. I think I
giant
have it
sign.
here, don't I?
We're right as you're coming into the area from eating. We're right there on the left-hand side. So
Yeah.
hopefully
You'll see
it.
HCL CamWorks, big circular sign. So if you have more questions, please feel free.